Thank you. Great, so many of you have managed to last the day. I was just looking for an appropriate graphic or meme or something to kind of show you. And I guess you kind of feel like this poor guy. You've been through a lot throughout the entire day, and this is the last session, so you know, I know it's kind of tough after lunch. You've eaten nice food and it's warm room. You're very easy to doze off. I've done it, so no worries. Okay, so just follow on from the last set of speakers. So those of you who are here and just heard those guys from CERN. So many years ago, when I was a lot younger and I was doing some research in database performance benchmarking, I had the great opportunity to go out to CERN. And at that time, you know, this was kind of 15 years before the LHC experiments, so they were planning way, way ahead in terms of the kind of technology that they wanted to use. And of course, in those days, the popular database technology was object-oriented databases. You know, who remembers them? Not many people, you know. If you look at Gartner's kind of technology clock, it's died. You know, the technology's gone. And then 10 years later, it was XML databases. Who uses them? Nobody, okay? And so the likes of relational, Postgres, MySQL, very popular, of course, and Oracle and SQL Server still very dominant in the technology space. Okay, so I kind of realized that because this is the last session, you know, I'm all that stands between you and the reception. So I will try my best to finish as early as possible. And I'll be around downstairs with the GridGain booth. So if you want to grab me, any questions or anything, issues, concerns, please feel free to reach out to me. Okay, so I'm a consultant with GridGain Systems. And so GridGain open sourced their technology to the Apache Foundation a few years ago. So if you go to Apache, it's Apache Ignite. There is a commercial version as well, which we won't touch upon today. So we're focusing purely on the open source technology. So ignite.apache.org, and it's a top-level Apache project. Originally started life as an in-memory data grid. You may be familiar with some commercial offerings in that space as well. But subsequently, it's kind of become you know, far more capable. It supports a range of features today, so a compute engine. It obviously does the key value store, which is historically where it came from, but other things like SQL 99 support, so you can view it as a distributed SQL database as well. And of course, as with everybody else in the world, machine learning capabilities and other things are coming along as well. So we won't touch on those today, but here's a quick kind of agenda then. Very brief, couple of charts just to give you a bit more information on Ignite. And then we'll look at some capabilities of Ignite for Spark. So Spark is a great compute engine, fabulous in terms of its capabilities, but there are some complementary things that Ignite can offer, which will, I think, be very suitable for certain use cases where you want to use the two technologies together. Now, you'll notice I've kind of talking about RDDs. So quite a few speakers mentioning RDDs still today. I appreciate that the community and Databricks and others kind of encouraging you to get off those and move on to data frames, data sets. But the thing is that at a low level, they're still very powerful, and it's a great feature to have. Ignite supports this capability today, but data frame support is in the works as well. And specifically, there's a reference at the end of the slides. If you want more information, the work is in progress, and that will be available, hopefully, in the very near future. A little bit on installation and deployment, and a couple of very, very simple demos just to show you how this thing actually works. Now, my machine's not very powerful, doesn't do a lot, so I can't fire up a huge cluster to be able to show you these things. So I'll launch a couple of small Ignite instances, and we'll run Spark and a Spark worker, and just do a couple of things there for you. Okay, so as I mentioned, it's a Ignite memory-centric platform, strongly consistent, okay? So ACID support, atomicity, consistency, isolation, durability, configurable, okay? So as you know, in cluster computing, one of the challenges is that how can you support consistency across your entire cluster? Very, very difficult to achieve. There are latency issues. There are problems in terms of maybe hardware, delays in terms of where the updates are done. So often it's quite a challenge. And therefore, with a lot of modern technology, I mean, if you look at the NoSQL world, for example, products like Cassandra and others, they offer this notion of eventual consistency, which is useful in some instances. But the ACID level is configurable. Okay, we realize that you could be waiting forever for some updates to be achieved, and it's never going to happen. Therefore, you want some configuration and capability there. High availability, that's, I think, comes as part of cluster computing. You expect that anyway. Durability and self-healing, the ability to fire up additional resources and add those to your cluster as you need them. Scale up, scale down elastically. It supports SQL, so SQL 99 support is available today, and you can view it and work with it entirely as an SQL database if you want, and that supports all of the DDL, DML, as well as indexing as well, both in memory and on disk. Okay, so originally, as I mentioned, it started life as an in-memory data grid, but now persistence capabilities as well have been added, so that's native persistence from Ignite itself. Okay, so it can do that for you. Or if you are using, say, a relational system, HDFS, or a NoSQL system, you can access that and use those capabilities as well. Key value store, again, historically, this is where it came from, but it supports a wide range of APIs as well, different types of processing, stream processing. It's got adapters for Flink, Spark streaming, Kafka, if you want to use those technologies. So it again, provides sort of complementary features and can act as a sink. So data can be streamed in. Ignite will consume that data. It will use its capabilities in terms of cluster-wide in-memory computing. And you can run your machine learning jobs. You can run SQL upon that data, process it, and then take further action if you want. Originally designed for two main problems, so performance and scale. So very much the motivation is no rip and replace, okay? So the idea is that if you've invested heavily in some existing technology, that's fine, okay? Use that as much as you want, but take Ignite and some of the features that it provides to help you scale up the data and give you performance as well. And you know that in-memory computing, storing things in memory and being able to process them at memory speeds, that gives you phenomenal kind of performance boost over having to do things from disk. Now, historically, if you look at things like SQL, for example, a long time ago when SQL was being developed, very much they chose to focus on disk-based optimization because memory was tight. It wasn't very cheap in those days. Today, both disks and memory, far cheaper. You can add a lot of memory to your cluster computing if you want, and you run these things at memory speeds, and you can process huge amounts of data very, very quickly. Okay, so data source agnostic, has compute engine, durable storage, which I mentioned a few moments ago, OLAP and OLTP, ACID transactions across both memory and disk. In-memory SQL support, again, gives you tremendous performance boosts. The machine learning libraries, kind of in the works, okay? So at the moment, it does some matrix algebra, but things like k-means and some of the other things that you might be interested in as a data scientist or a machine learning specialist, they're in the works, okay? And integration with TensorFlow, deep learning, this is coming along as well. Not quite a large community as Spark, but it's growing. And if you want to participate, I mean, the Apache Foundation is a great way to sign up to the dev list, get involved, and be able to contribute to the project. And I encourage you to do that if you are really interested. Okay, so some of the reason that you might want to share state in Spark, well, long-running jobs, particularly if you're working in some areas like machine learning, for example, where you've got lots of models that you want to test. You may have jobs that take a long time to finish. I mean, even today, this is the issue, I think. Long time ago, I mean, a lot of the algorithms and the ideas behind machine learning are nothing new. It's just previously processing was an issue in terms of how can we do this much faster. Today, of course, some of those challenges and problems have been resolved, but it's still an issue. I mean, you may have far more data to be able to analyze. I mean, look at the guys at CERN, for example, from the last session. They're working in petabytes, and even the experimental setup at LHC, for example, they were going to generate sort of 40 petabytes or more, each time they run one of these experiments. That data has to be kept for a long time. So these are kind of problems that a lot of organizations have. Now, most of us are probably not going to work at that level, but still we may be working in the high terabytes, challenging the kind of petabyte range, low level. So still there's a lot of data that we need to analyze, and therefore storing state is a good thing. Historically, then again, what might we do? Well, typically then if you're working with RDDs, then you might have to convert these and store them to disk and be able to save the state that way, subsequently read it in another application. Not ideal. So one of the things that this kind of approach provides is to give you the ability to actively use Spark APIs as well as Spark transformations directly in memory. Okay, so what is the Ignite for Spark then? So it's an RDD abstraction. Basically, because Ignite offers this kind of in-memory cache, what they've simply done is wrapped it as an RDD. Okay, that's principally what you get. It's shared in-memory view on data across different Spark jobs, workers, or applications, and the graphic kind of illustrates it in a fairly nice way there. And as I mentioned, implemented as a view over a distributed Ignite cache. So Ignite is a distributed hash map, okay? Again, it's a peer-to-peer system. There is no master-slave. You can have primary copies of your data, backup copies of your data, and as many backup copies as you like, okay? So that's one of the nice features. But essentially what it is just the Ignite cache that you create wrapped up as an RDD, and you have all of the capabilities that you have with an RDD that you would get in Spark, but now you can do so through Ignite. Some of the ways that you can use it then, you can use it directly on a host, through an application, or globally, okay? And we'll talk a little bit more about that shortly. And then the state itself that you might want to store, you've got a couple of choices. Either standalone, where it outlives the Spark application that created it, so you may want to store that data beyond the lifetime of the process that you're working with, or it could be embedded, and therefore you're just running it in that Spark application. At the end of it, you lose that. I mean, that might be something you want to do. Something else that could be useful is this kind of in-memory file system. Just one slide on this, not really worth covering too much because it doesn't have significant bearing on the RDD approach, but something to keep in mind is that, again, this can provide a real big performance boost in terms of the type of processing you do. It's a direct kind of replacement for HDFS, but entirely held in memory, okay? So all of the APIs that you would require and how you would work with the HDFS, you can replace that entirely with this in-memory file system. Okay, so let's have a look at Ignite Context and Ignite RDD. Okay, so Ignite Context. Just as we have with Spark Context, it's a main entry point, okay, to the Spark Ignite integration. Two ways that you can use it. Either you set up this Ignite configuration, or you pass a parameter, sort of an XML file that contains a range of attributes and sort of capabilities that you want. In the demos that I'll show you very shortly, I'm actually using the XML file. It's a little bit easier for me. There's also some Boolean arguments as well. Remember we talked about the sort of mode of deployment. So you can set this client argument to true or false, and that gives you some capability as well. Again, in the demo a little bit later on, I'll show you how we can use this. So in terms of simple code example, then here is how we could apply this. So again, we take the Spark context, and then this is just using Scala code, and we have the two choices shown there. And as part of the Ignite distribution that you can download from Apache, it comes complete with this example, shared RDD.xml, that you can just use straight away. And again, that will be easy to find. You can set the names in there for the cache. So think of the cache a little bit like a collection or a relational table, if you like, and it's just shared across your cluster. I mean, it's just a named way to be able to access some data that you want to be able to store. As far as the Ignite RDD then is that, as we mentioned before, it's a live view of an Ignite cache, okay? It's mutable, unlike the native RDDs that you get with Spark where they are immutable. The reason for this is that, I mean, if you're providing a wrapper over a cache, then the way that Ignite works is the cache is readable and writable, and therefore this is a kind of a natural extension to that. It will provide some information in terms of partitioning, okay? So the data are partitioned a certain way, okay? As I mentioned, it's a distributed hash map. You apply an algorithm, it knows how that data can be partitioned. That information is provided to the Spark executor. And additionally, there's some affinity information as well. So that if you co-located some data, for example, or there is some locality of data that you want to use, that information, again, is provided to Spark to be able to use that to, again, speed up the execution process. How to write to Ignite, then? So the way that at the lowest level that Ignite works is its key value. And, of course, the value can be anything. But there's a kind of a nice natural translation between a key value and the way that Spark works in terms of tuples. Okay, so the code examples utilize this capability, and this is a nice sort of clean way to be able to represent one within the other. And we have a method called save pairs, which will help us out here. This will take care of the RDD partitioning. There may be instances, of course, where you don't have a key, okay? Maybe just a value, in which case there is an alternative save values method that is available that can help you, and the Ignite RDD actually generates some affinity local key which can be used in this case. As far as the sample code, then, let me just show you some simple examples. Hopefully you can all see that reasonably well. So this is just creating an application. We get our Spark context. We create the Ignite context from the Spark context, as well as passing the XML configuration file. And then we've got this shared RDD, which is just the name of the cache that I've chosen. It could be anything that you want. And that's it, really. That's very, very straightforward, very simple in terms of setting this up. And then subsequently, you can just perform the write operation. So right at the bottom there, you can see we're doing a very simple kind of 1 to 100,000, 10 parallel operations, and then just doing a map. Very, very straightforward. Nothing particularly complex there, but useful for illustrative purposes. In terms of the read, then, again, because the Ignite RDD is a live view of the cache, there's no sort of additional work that we need to do here. The RDD methods are available to use straight away. So in terms of the code, then, here we go. We do similar sort of setup to what we did previously a couple of slides ago, just called it a slightly different name here. Again, we get our Spark context. We get our Ignite context based upon the Spark context. We again need to define the cache that we're going to use, which we previously defined, shared RDD. And then in this case, we're just performing a filter and then providing some output here. So very, very straightforward. So, okay. As far as installation and deployment, then you've got a couple of options available to you. Shared deployment, embedded deployment, Maven, SBT. I'm fairly new to Scala and SBT, but I was able to use it just recently to do a build without too many problems, although I kind of like Maven, so that really was the speedy way for me. But we'll look at a couple of these things. So shared deployment, so standalone mode, Ignite nodes deployed with Spark worker nodes, and again, the demo very shortly, I'll show you these. Some information that we need to tell Spark about because it doesn't know where some of the Ignite jars are. Okay, so we need to amend the Spark m.sh as it starts up. It will pick up some information in terms of where various jar files are that Ignite actually needs to run, things like log4j and other things for its own purposes. And this is kind of important because as part of the Ignite distribution, there is a libs folder, which has a whole range of optional kind of libraries that you can use working with a range of technologies, as disparate as sort of Cassandra and Redis and others, but Spark is one of them. And therefore, all we need to do is just make sure that Spark is aware of the things that we want to use. Anything that you leave within the optional directory, just ignore it. It's not used. Embedded deployment. So in this mode, Ignite nodes started inside Spark jobs and stopped when the job dies. Okay, so the process dies, then the Ignite also dies. Ignite code distributed to worker machines using Spark deployment mechanism. So again, nothing special there. Let Spark do all the work for you. And finally, Ignite nodes will be started on all workers as a part of the Ignite context initialization. So once you've done that, again, nothing more to do beyond that, okay? So that keeps things very, very simple. In terms of Maven then, all you need to do is just add the dependency, and it's as simple as that, okay? So really, the build process is quite simple and straightforward. And if you're working with SBT, then again, it's very, very simple and straightforward in terms of the library dependencies. Can be some issues I noticed recently when I was working with this and trying to use the latest versions of Ignite. It comes up with some errors, but unrelated to Ignite, but other modules that it's kind of picked up. So that's something I need to look into, but it's just my lack of experience, I think, in this area versus any problems that are specific to the actual build. Okay, so very, very simple and straightforward. Okay, let's do a couple of demos then. So I've got just over 9 minutes. So hopefully this will take just a couple of minutes and we'll be able to get you away on time. All right, now I'm terrible at typing because I've got fat fingers and I hate this Apple keyboard, which is very unresponsive. And so I'm going to copy and paste, okay? And so let's, and I'll blow the screen up, okay, and then show you what I'm doing as we do it. All right, so here, okay, we're just going to launch Spark Master, okay, so here. All right, there we go. So we've done that. It's very, very straightforward. And we'll get ourselves one worker on here as well. Okay, so open that up in this window. So there we go. All right, now I've disabled the logging and the info, okay? Otherwise it gets too verbose and you can't see what's happening. So I'll just, that's the reason it looks as though nothing's happening, but trust me, it's running, okay? So if we just go over here and have a look at localhost, and I've set it to port 7080 so as not to conflict with other things, okay? So there's our Spark Master running, and if we kind of zoom in, we can see that, in fact, we've got one worker running as well, which is exactly what we want. Okay. Now, you'll notice that I've got a lot of these terminal windows open, so I'm going to fire up a couple of, I should disable Little Snitch, otherwise it's going to keep popping up with errors and problems. Okay, so let's get this. All right. So what I'm going to do in a couple of terminals, okay, so let me just zoom in and just show you again. So this is just launching an Ignite node, passing that XML configuration file, okay, because we want these nodes to be able to find each other, and as we do that, that forms our cluster, okay. So we'll just fire that up, and that will run one there. Okay, and I'll do the same in another window over here, so we get another one. Okay, so there we go. And you'll notice here in the windows, it's got servers equals 2, okay? So originally this one was servers equals 1, so these two nodes have kind of found each other, okay? Very, very simple, because they're using the same configuration file, we've got the same ports and everything else set up. Okay. All right, now, one of the things that we can do in terms of monitoring what's kind of going on is there's a fairly cool web-based tool. And I just need to launch the web agent, okay, so that we can see what's going on. All right, so this is again part of the standard distribution, and you can download this as well. So you'll notice here that it's running on port 8080, and it's already picked up the fact that there's a cluster running here with a couple of nodes. Okay, so we fired up 2 nodes. It's being able to find that information. And within our web browser, if we just open up a new window. Right, now, those of you who are sharp-eyed, you'll kind of see that that went to console.gridgain.com, not where you really want to be inside your corporate environment. It's just I'm a bit lazy and didn't set this up properly for the local machine, but you can do that, okay? So this system can be entirely self-contained, and within a corporate environment, that's exactly what you want. So this tool will just give us a little bit of information in terms of what's going on as far as the cluster is, what sort of the cache size is. Here we've got some information, for example, in terms of the couple of nodes that we fired up. So they've got their own node IDs, they're running in server mode, we've got IP addresses, and there's not very much going on at the moment, so there's not a lot of activity to show you. If we scroll down here a bit, we can see now this kind of shared RDD is the name of the cache, okay? That's what we've created. So we've got Spark running, we've got one worker running, we've got a couple of Ignite nodes running. Nothing else at the moment, as you can see. No data have been put in, no data have been taken out. There's no activity for the moment, okay? So let's just have a look. And what we'll do is taking that code example that I showed you in the slides, just to be able to write some data in. Okay, let me just zoom that in for you again, just show you. Okay, so we're just doing a Spark submit, RDD writer, and then just passing the Spark address there, and again, giving the location of the jar file, which is where I've packaged this up. Okay, so we'll launch that. Now, it's kind of unexciting, okay? You won't get very much output because all it's doing is just putting things into the cache at the moment. Okay, so it says console logging handler is not configured. Okay, that's fine. But if we just give that a moment or two, you'll see a bit of activity in the other windows there where I've got Ignite running. So there it's recognized the fact that some additional resources have kind of become available, some added servers, and as part of the process that is going on. And now if we just run the reader, okay, so let's just zoom in. Okay, now it might look a little bit slow, but as I said, the machine's a bit underpowered. You know, there's quite a lot of stuff that's actually running, although memory is being used reasonably well, I think. And I think it should be enough to sort of demo the purposes. Okay, so there we go. So it's just doing a little bit of analysis. I'm just doing a search for how many of these kind of 100,000 values, you know, filtering how much is bigger than 50,000. Well, it's 50,000. Okay, that's the answer. So there we go. Okay, so because this is a live cache, it's still available, I can kill my Spark worker and I can kill my Spark master, which I'm going to do. Okay, so just kill that off, and then let's shut down the Spark master properly and just do the stop. There we go. So now if I switch here to the IDE, what I have is a Scala application here, which again, if I just zoom in here for you, okay, so it does a little bit more. It's a bit more featured and has a bit more in terms of what it's doing versus the just sort of standalone applications that we ran. So here, it's going to launch its own Spark master and a couple of executors, okay? It creates the Spark context. sets the logging level, again, using the config file, which I previously used, creates the Ignite context. Just get rid of that. And again, we just point to the shared RDD, which is just the name that we are using for the cache. Okay, scroll down a little bit more just to show you what's happening here. Now, this application actually originally does pretty much what I did with the standalone writer application. So it would create a list of 100,000 parallelized and then just map that to sort of key values. But in this case, I've commented that out. But what's going on is doing a little bit of arithmetic there for you. You can see X times X. It's doing a bit more there in terms of a little bit of math, arithmetic. And then it's doing some filtering, a little bit different from what the filtering we previously did. And then down at the bottom there, you can see some SQL statements there as well that are being run. So it's a combination of both Scala, key value if you like, it's being manipulated, as well as SQL statements as well. So we can run this. From here. Okay, just make this bigger. Okay, so there we go. So it's done a little bit of transformation there. And then it's just done some SQL statements to some queries over that data. So again, you can see very simple, very straightforward, but extremely powerful in terms of its capabilities. Okay, so this can be a useful way to be able to share state across multiple Spark jobs, if you like, and have the ability of Ignite to manage that for you. So it's a complementary technology, not meant to replace Spark, but add some additional sort of features and capability to what Spark can do. Okay, so in terms of resources then, oops, I think this is a little bit, oh, there we go, that's okay. So Ignite documentation, readme.io, the DataFrame support, which I mentioned a little bit earlier on. Okay, so there's a Jira ticket out on that, and there is sample applications that are being built, patch that needs to go in. It hasn't been approved yet. I think it's under review, but expect that to be out very, very soon. Okay, so if you're particularly interested in DataFrame support, and SQL support is already there as far as Ignite is concerned, very much so in terms of how you're going to manipulate your data frames. That's a good way to look at it. And again, as part of the standard distribution that Ignite comes with, the Scala examples, Java examples that you can play around with, the 2 bits of code that I ran a little bit earlier, they come as part of this standard distribution. Okay, and get involved, ignite.apache.org. So if you're interested, sign up for the dev list, participate if you want, that'd be really awesome. And happy to take some questions. Out of time though, but there we go.
All right. Unfortunately, we've run out of time, so we don't have time for questions. But as Akmal said, he'll be available at the expo hall, and you can ask him questions there. And yes, let's head down to level 0 at the expo hall, and we have some beers and snacks available for us. And
okay, great.